Now, before we go any further, let me give you a brief idea about electrical system management. Since you are studying alternator, you should have a good idea about these things. The first of all is the load variation or load fluctuation. Load fluctuation. First point. Second is the spinning reserve. Spinning reserve. Then you have non-spinning reserve, and you have supplement. So, what are these things? Now, let's try to understand the load, how the load actually varies, okay, over time. So, if I try to plot a curve like this way, load curve, okay, this is the hourly load. Okay, this is the hourly load I want to plot, and so this is time per day. So, say for example, this is my 00, start of the day. I am at 6 a.m., then I am at 12 a.m., then 18, then 24. Okay. Now, at 12 p.m. the load can be a little bit higher, but gradually at 2, 3, the load gradually decreases. Okay. Then at 7, 8, suddenly it starts to increase. And it is at noon it also remains something constant. At the evening it suddenly gets a peak. Okay. At night it suddenly becomes a peak value, not like this, higher. For a few hours it remains at peak. Then at 12 p.m. it starts to decrease again, and slowly starts to decrease like this way. So as you can see, the load actually varies over the day. It does not remain fixed. Okay. So at certain point of time it is small. At some particular amount of time the load is actually varying. It is not fixed. So you can draw a baseline here. You can draw a baseline something like this. Okay. Somewhere like this. Okay. And this is called the base load. Okay. This is called the base load. That means this is something is always there. Okay. The base load is always there. And these are some fluctuations. It is very much uncertain that how it is going to be in a particular day. It depends on many different factors. Now, so you actually keep some reserve. This is called the spinning reserve. You try to estimate, forecast the hourly load of a day before the day, and you try to keep some reserve along with it. So this load fluctuation. So first of all, you have to have some generators, some power plants operational that is running to supply this load. Okay, and think of it like the perspective of a country. Okay, you're supplying this load. You also need to keep some spinning reserve, because you are not sure that this is going to be exactly like this. So you need to keep some reserve. So these reserve loads are not connected to the grid. Okay. These are not connected to the grid, but they are on. They are on. If needed, they can be connected to the grid. Now this non-spinning reserves, this means this requires almost 10 minutes to connect. Okay, to turn on. They are not turned on. Okay, but they are operational. They can be operational. Okay, but that requires some time to turn it on. Okay, these are called non-spinning reserve. Okay, and the supplemental reserve is for extremely rare cases. Now, so the first of all, this means you have to supply some current, through some alternators, that is power generation, through some power plants. You have to ensure that you have satisfying this load fluctuation, because say if in terms of watt, let's name it 5 kilowatt, 5k, let's take it 10k, okay, let's take it 15k, okay, let's take it 20k. So in terms of daytime, at this hour the load is very low, that is you only need 5 kilowatt. Okay, but suddenly in the evening, in the same day, in the evening you need almost 20 kilowatt power. That's a huge variation. Okay, this is called a peak. Okay, this is called peak, and this depends on many different factors. So for example, if there is a like 31st December, okay, suddenly the load might increase. Okay, So this kind of special days, the load actually peaks at a particular amount of time. So you have to have some preparation, otherwise you have to do load shedding. Okay, so you need some preparation from the electrical system management side, that your plants, the plants that you have, they are able to supply all these kinds of things. They can supply this load fluctuation. Okay, they can handle this kind of load fluctuation. They also have some spinning reserve, so that they can actually still handle some kind of variation there, and also some non-spinning reserve is there for some peak value. Okay, certainly the peak can even increase further. Okay, so if you want to provide a good management, a good in the supply side, in the demand side, if you have to provide always supply, continuous supply, you have to manage these things. Okay, through the operation of plants. Okay, now to understand how these plants operate, you need a little bit more idea. Let me give you that. Okay. There are two things. First of all, one thing that is called the ramp rate. So what is ramp rate? Ramp rate means how fast, okay, how fast you can increase or decrease, or decrease supply. Now there are different types of plants. Okay, in Bangladesh there are different types of plants in all over the world. Okay, so what are the plants? The plants can be nuclear plants. Okay, I'm using syllable only, nuclear plants. Okay, for nuclear. Okay. It can be coal based plants as well. Okay. It can be combined cycle plants. Okay, or it can be combustion engine plants. Combustion. Okay, combustion means natural gas or diesel fuel, something like this. It can also be hydro plants. Okay, there are different types of plants there. Now they have different way of operation. How they differ? Now the ramp rate is how fast you can increase or decrease the supply. That means if I plot a graph here like this way, if I plot a graph here, okay, this is your ramp rate. Okay, so if I draw a bar plot, the bar plot will be for nuclear plant, it is very small. This is N. This is a nuclear plant. For coal based plant, it is also very small. For combined cycle, it is a bit higher, and for combustion engine, it is very high. Okay. So what does it mean? It means that when you are operating a nuclear power plant, okay, it cannot change the supply, that is the output power that is providing. So say a nuclear plant is providing 800 watt, you cannot just change it output power very easily. Okay, just say within a few minutes you will increase it from 800 to 1200, you cannot do that. Or you will decrease it from 800 to 400, you cannot do that. Okay, so a nuclear power plant cannot change its output that easily. So understand, it is related to this one, your hourly load. So if you are operating your nuclear power plant and you are solely operating on a nuclear power plant, you can supply this base load, but you cannot actually supply this peak load, because you cannot change the output power of nuclear power plant so easily. Okay, so similarly goes for coal based plant. It also cannot change its output power so easily. Okay, so the ramp rate is based for combustion engine, natural gas. You can increase the supply of gas, you can also decrease the supply of gas very easily, and very within a short period of time you can increase the load. Okay, so you can think like this way, that here when you want to, how you want to actually manage your system, this power plant system, that is for base loads you can use your nuclear power plant. You cannot use your nuclear power plants for the peak loads. For that, the best suitable option is natural gas based plant, because you don't know how high it is going to be. So if you have your natural gas based plants operational or in spinning reserve, only then you can supply those things. So you have to manage it that way. Okay, again there is another factor that is called the runtime. Okay. Yeah. Runtime. What is runtime? Not only runtime, this is minimum runtime. Minimum runtime is, understand, you are supplying power through some generator, but the base, that is the turbine that needs the providing the mechanical power, it is done through this option. It can be nuclear, it can be coal based, it can be combined cycle, or say natural gas based plant. Okay, these are the basic fuel of your alternators. But once you start a nuclear power plant, you cannot just turn it off that easily. There are some certain procedure how to turn off slightly gradually. Okay, so the runtime, minimum runtime of nuclear power plants is very high. So it is like 100 hours. In hours, it is very high. Coal-based plant, it is also higher, okay, but much lower than nuclear power plant. Nuclear power plant is too high. Okay, it is smaller because once you turn on your coal-based plant, that means coal-based generator, you cannot just turn it off. You have to keep it on for certain amount of time. Then you have CC, that is the combined cycle, and the smallest one is the natural gas. It is very easy. So it looks like to you, it might look like that the natural gas plants are the most easy way to do it, most flexible, you can think of like this, the most flexible to operate, but it also comes with additional cost. If you look at the cost of operation, if you look at the cost here, and let's say this is the flexibility of operation, this is the flexibility, so the nuclear plants are the lowest. Okay, the flexibility is very low, the cost of operation is also low. It has a high capital cost, but the fuel cost is very minimal. The second one is your coal based plant. It has a cost of coal. Okay, the flexibility is also somewhat level. The combined cycle is here. The cost is increasing, the flexibility also increasing, and the highest one is the natural gas plants. They have the best flexibility, highest flexibility. The cost is also very high. Okay, it requires a huge amount of natural gas supply or fuel supply, and this is operational cost. Every day you need to feed these things continuously. Okay, so to have a very good management system, what we do here is that the nuclear plants and the coal based plants, we call them base load plants. Okay, these are base load plants. They are to supply the base loads. Okay, the base load that you need every day. The CC, the combined cycle, this is called load following plants. Load following means after the base load there is also some supply. It gradually increase or decrease. This base supply, out of that base supply, that is actually normally supplied by this CC plant, combined cycle. And for the reserve, that is the peaking plant, okay, the natural gas plants, these are kept for peaking. These are called peaking plants. This is for supplying the peaking when the load is at its peak. At those hours, natural gas plants is used. Again, the longer you run this natural gas based plants, the costlier is your operation. So the cost of operation increases very high. Okay, that also related to the electricity bill. So there are lots of related issues are here. Okay, so for a better management system, you need all these kind of plants. This one. Also hydro plants. If you look at the hydro plants, they also have a very good ramp rates. Okay, that means they can be very easily increase or decrease. The supply can be very easily controlled. But again, hydro plants are not always available. The water is not always available. There should be some water reserve in the reservoir so that you can actually supply the hydro energy. Okay, so there are based on this base fuels to run your generators. So you have a generator from nuclear power plant. Okay, you have say JN. You have another generator, say alternators. You have another alternators from coal-based power plant. Okay, you have another generator or alternator from your combined cycle power plant. All of these generators, these are connected all together. All of these generators are connected all together, something that is called your grid, your national grid. Why they are connected? Because for a single generator, it is not possible to supply the load. The demand load is very high. A single generator can supply that. So thousands and thousands of generators, okay, are connected to the national grid, and national grid is like a medium through which you are fulfilling the demands. Okay.